Something new is happening on the moon. The year is 2050. Humans are scratching out a living, despite the merciless conditions. Sun hotter than the Sahara. Shade colder than Antarctica. And a life-sucking vacuum that kills in minutes. But in the rugged wilderness of the lunar South Pole, on the rim of a crater twice as deep as the Grand Canyon, bustling settlements sprout out of moon dust. Corporations and nations compete against one another, exploiting the moon's resources for profit, science, and military advantage. This is no sci-fi movie, because people are already making it real. Around the globe, Earthlings are now preparing themselves for life on the moon.
Please make sure all shoulder harnesses are securely fastened. In a few moments, we'll be landing at Shackleton Lunar Spaceport.
VFS, see the roll.
Welcome to the future.
That's affirmative. Copy.
The moon has been transformed from an alien world into an extension of Earth. The first human outpost on another world. And our first decisive step toward becoming a spacefaring species. But whose moon is it? India, China, Japan, Russia, Europe, and the United States all want in on the action.
Falcon 9 is the most powerful single-core vehicle in the American fleet.
Not to mention entrepreneurs.
Today, there are 1,200 billionaires on this planet. And what it used to take a large government agency to do, a small group of dedicated individuals with the right computational capabilities can now do.
Private or government, foreign or American. To get to the moon this century requires that everyone must overcome the same set of hurdles. Because there will be nothing on the moon until humans put it there. No shelter, no transportation, no food and water, no electricity, no spacesuits, no landers, nothing. Every person, habitat, vehicle, nut, bolt, and scrap of food must be lifted off the Earth and transported 250,000 miles through space. Step one for getting back to the moon is also the hardest. Get this unprecedented load out of Earth's gravity.
Escaping Earth's gravity is kind of like climbing out of a well. And you start out at the bottom of the well. And it's going to be a lot of work to climb your way out.
NASA calls its new moon program Constellation. Plans call for not one rocket, but two. Put people on a small rocket, which will be called Ares 1. Put everything else needed for a lunar settlement on a larger rocket, Ares 5. This monster will stand nearly 400 feet tall.
Liftoff of the Delta rocket carrying blast,
and
a
be
gamma ray
the largest
telescope
rocket
searching
ever
for
built.
unseen physics in the stars of the
Together,
galaxy.
these two rockets will be able to lift twice as much as the giant Saturn V rocket of the 1960s.
15 seconds. Guidance is internal. 12.
40 years ago, during the Apollo program, it carried astronauts and all their equipment to the moon. But the new Ares 5 will carry 10% more.
Instead of having a maximum payload of about 48 metric tons that the Saturn could deliver, you can probably get that up to about 54 metric tons, which means that you can have a larger landing vehicle. You can take 4 crew instead of 2. Just a whole bunch of additional advantages for having that larger payload.
But designing two new rockets can take years, and lots of failures along the way. So NASA's not going to start from scratch.
What we've come up with is actually to use heritage systems off the shuttle and Apollo, which, number one, gives us a lot of reliability data. We have a lot of experience with flying those, so our likelihood of failure goes way down.
The first stage of the crew vehicle, Ares 1, is a solid rocket booster. It's the same one used on the space shuttle, but extended for more power. The second stage has an update of the 1960s Apollo engine. The heavy lifter, Ares 5, will be powered by two of the same larger shuttle boosters, and a cluster of 5 main engines derived from the ones used on another large rocket, the Delta IV. NASA engineers have spent 50 years making their launch systems safer and more reliable. But tragic accidents happen.
Engines beginning throttling down now.
When the shuttle Challenger blew up 73 seconds after launch in 1986, there was no escape system, no way for the astronauts to survive. That's a design mistake NASA's determined not to repeat. The new crew capsule, called Orion, looks a lot like the old Apollo, only larger. And like Apollo, it will have a way to save the crew from disaster.
On Orion, we actually have a launch escape system, launch abort system, that allows us to abort at any phase during the launch.
The launch abort system is another small rocket mounted on top of Orion. If something goes wrong during launch, the abort system's powerful engine can instantly fire, pulling the capsule and astronauts clear at 600 miles per hour. For several seconds, they must endure the high G-forces normally experienced by fighter pilots before parachutes open, returning them and their capsule to Earth, shaken but still alive. As of today, NASA's aiming to have Constellation's lunar program designed, built, tested, and ready to launch in 10 years.
Final launch readiness poll, VM.
It's the year 2020. At the Kennedy Space Center, the Orion capsule and its crew of 4 are just seconds away from heading back to the moon.
Ignition, we have liftoff.
Once off the launch pad, Ares 1's first stage solid rocket burns for just over 2 minutes, punching the Orion crew capsule through the air at over 4,000 miles an hour, more than 5 times the speed of sound.
We're coming up on stage 1 separation event.
The spent first stage then separates, and the second stage fires, carrying the spacecraft to an altitude of 83 miles above the Earth.
We have confirmed bearing separation.
No longer needed, the launch abort system is jettisoned. Orion's service module engine takes it into low Earth orbit, 200 miles above the planet.
Avionics and booster power systems are nominal.
Orion then unfurls the solar panels that will supply power. The first step of the new lunar mission is almost complete. The people are off the Earth. Now they need their equipment. Ares 5 blasts off next, carrying everything the crew will need for step 2. Getting to the moon.
Copy, Vince.
But to do that, the 2 rockets must first execute a critical maneuver. Rendezvous. It may look simple, but it's not. To pull this off, the astronauts need precise control of the Orion capsule. Designing those controls and making sure they'll work is up to Jeff Fox.
Now when you get to orbit, you'll be able to unstrap, float free, move a little closer to the display, angle yourself a little bit different. You may remember Apollo, there was a lot of manual dials and gauges and switches.
Now, astronauts will control Orion from just 3 glass panels.
And I can select the BDAP here.
They test these controls in a flight simulator.
We're about 18 feet out from the docking port with our docking port. So this is what we call the final approach. It's going to be about a 2-inch wide target that we have to hit.
But docking in a simulator is no substitute for the real thing. They might appear to be floating, but these 2 vehicles are now moving at 17,000 miles an hour. Trying to dock them is like playing the ultimate video game. Only here, there's no room for error.
Lock our good day.
All vents open.
It's 2020. Americans are heading back to the moon. The Orion crew capsule draws ever nearer to the giant Ares 5 cargo ship. Finally, the 2 vehicles dock safely. Now it's time for step 2 to begin. The engine on Ares 5 burns once more, pushing the crew up to 24,000 miles an hour, enough to slingshot them out of Earth's orbit and on to the moon. 4 days from now, they'll look down on a surface area as vast as Africa. So where should they land?
The Apollo missions went to the equatorial and lower latitudes because those were very accessible from Earth. The lower latitudes are easier to get to from a rocket point of view.
The moon's equator is also flat and relatively boulder-free. And since no Apollo crew spent more than 3 days on the moon, having enough light was never a problem either. They landed in the lunar morning, and a lunar day lasts 2 weeks. The problem is the lunar night, which also lasts 2 weeks. Astronauts can live off solar power for 14 days, but then they'd have to find a way to survive 14 days in darkness. It's not just dark, it's cold. 250 below zero, 4 times colder than Antarctica in the dead of winter. And without solar power, it could be deadly. The astronauts must find a reliable source of power.
You know, the best place that we could possibly go on the moon, if we're engaging in a frontier approach to space, where we're going to get there and build and grow something, are the poles.
The moon's orbit exposes both its north and south poles to virtually continuous sunlight. Bathed in that sunlight, almost exactly at the South Pole, is Shackleton Crater. But there's a problem. The Shackleton Crater's steep walls are twice as deep as the Grand Canyon and climb to a ragged rim. No pilot in his right mind would attempt to land there. And it's uncharted territory, the perfect graveyard for a spacecraft.
Bravo 1.
NASA engineers don't want a repeat of the first lunar landing in 1969. Few watching then realized it was a near disaster. A few hundred feet above the surface, Neil Armstrong discovered his lander was headed for a field of large He quickly looked around for a better spot and manually steered his way toward it, coming within 30 seconds of running out of fuel. The last thing NASA wants is for the new mission to face the same problem. So, step 4 for getting back to the moon is to find a safe landing site. But right now, the best maps of Shackleton Crater aren't detailed enough to reveal any large boulders that could cripple a spacecraft. To avoid that scenario, NASA will soon launch a new satellite called the Lunar Reconnaissance Orbiter, or LRO. If it works, the LRO will produce high-resolution images, the first step toward pinpointing the best landing site at the rugged South Pole.
Okay, let's reel it over.
The cameras on the spacecraft will be able to photograph individual rocks as small as 18 inches across. The LRO is also fitted with a new laser altimeter that'll help reveal the shape of those rocks by collecting topographical and temperature data to create 3D maps. Red and yellow mark steep or rocky danger zones. Green means flat and smooth. It's 2020, day 8 of the journey bringing Americans back to the moon. Thanks to the LRO, they're already armed with a map to the best landing site. The Orion capsule has brought the crew over 99% of the way to the moon. But the last few miles will be among the most treacherous of the journey. For that, they must transfer to a completely different craft. Step 5 to return to the moon. Design a craft that not only can land 4 people safely, but house them for a week. This is the first full-scale model of the lunar lander, Altair. Design engineer Clinton Doris's job is figuring how 4 astronauts can live out of this confined space for 7 days.
You see we've got one of these bunks set up. There would be 3 bunks vertically here, and then somebody that sleeps on the floor in essence. But this gives us the opportunity for all of our food storage and equipment storage. We've got storage here for our umbilicals. We've got a restroom facility, so to speak, but this is where all of the activities occur.
With cabin space so limited, the astronauts will have to ride down to the lunar surface standing.
Okay.
It's designed to fly only in the moon's reduced gravity, so Altair could never be realistically tested back on Earth.
Turn to the left.
This will be the first and ultimate test of how it performs as it negotiates treacherous slopes and deadly boulders. And no one has ever even attempted to land in a place like this one. On the edge of a lunar crater 2.5 miles deep. In 2020, the lunar lander Altair's on its final approach to the moon. But this landing site is a far cry from the Sea of Tranquility where Neil Armstrong touched down over 50 years earlier. This is a slender ridge near the yawning abyss of Shackleton Crater on the moon's south pole. It's surrounded by some of the most intimidating terrain humans have ever laid eyes on. Crater walls plunge down more than 2 miles, twice as deep as the Grand Canyon. The low polar sun creates glare and confusing shadows. That makes navigation difficult. Worse still, the moon has an unpredictable gravitational field that could throw them off at the last minute. At last, the astronauts feel a reassuring bump as Altair touches down near the crater rim, site of the future lunar outpost.
Go up through the crater.
For the first time in 50 years, Americans once again set foot on the moon. Harrison Schmitt is one of just 12 Americans who have walked on the moon.
I think the biggest surprise for me was just how beautiful the place was. Here's this brilliant sun that's illuminating everything like you were in the high mountain country of the Earth or in the deserts, but the sky's black instead of blue.
That blackness hides a stark truth. There's no atmosphere on the moon, only a life-sucking vacuum. Humans wouldn't survive here more than a few minutes without one of the most complicated pieces of technology ever devised, the spacesuit. Nothing less than a wearable miniature spaceship, the suit must deliver air to breathe, warmth in the shade, and cooling in the sun. The Apollo suits of the 1960s were rigid, bulky, and only good for a few days. So step 6 of the new mission is to devise a spacesuit that can last for several months and is easier and more flexible to move in.
That's a unique challenge because it's like inflating your tire. The more air you add into the spacesuit, the much more stiff it becomes, and much more difficult it is to move. So that's definitely a design challenge that we have to overcome.
Even the gloves are inflated with air, making it hard to bend your fingers.
Oh, man. You're talking about very stiff, unforgiving gloves. And not only do they wear your forearm muscles out very quickly, but it can also cause trauma in various parts of the hand. And we have to do much better with the next generation of spacesuits.
And figure out a better way to put them on. Unlike Apollo, the next generation of astronauts going to the moon will be able to slip easily into the back of their spacesuits. This will cut prep time for a spacewalk from several hours to just 30 minutes. The Apollo suits seemed to work well at first in the moon's reduced gravity, just 1/6 our own. But then they turned out to be top-heavy.
It is suggesting now is that we definitely want to get a center of gravity that's close to our own.
A punctured suit could have been lethal. Luckily, it didn't happen.
The guys were falling down a lot, actually. We analyzed the videotapes, and 2 to 3% of the time they were either falling down or getting back up.
But the falls caused another problem.
And so their suits got very dusty and dirty, and then they didn't have an airlock, so they had to climb back into the lander, and they got all that dust all over the lander.
Moon dust is deceiving. It preserves a footprint like fine powder. But under the microscope, you can see it's made of particles as jagged as glass. Worse still, it's statically charged, clinging to virtually everything. A deadly menace to equipment, machines, and even people.
So, yeah, we don't want to breathe dust. No question about it. What do we do about it? Well, the primary source of dust in a habitat would be the suit. Leave the suit outside.
But for astronauts to leave suits and dangerous dust outside requires step 7. A permanent outpost. To build that, they'll need supplies. Lots of them. Delivering them is another job for the Altair lander, which flies unmanned when carrying cargo. These cargo flights deliver the vehicles and materials needed to set up the lunar outpost. NASA's already testing the prototype lunar rover that'll be used to transport construction materials. But the outpost itself is still a work in progress. Engineers are evaluating many different types of habitat design.
We've looked at what if we had just one large module that had maybe 500 cubic feet of space to house four astronauts. Or if we had smaller tube type modules to build a larger facility. If something should happen to one module, you could quarantine it off and the crew could stay safe in the other modules.
The big concern is weight. Habitation specialist Robert Howard evaluates a design that's both light and compact.
We're now inside the inflatable torus. This is a mock-up of one of the systems that the Lunar Surface Systems Project is considering for living on the moon. If you notice the curved outer wall and the beams that represent an aluminum core, you can kind of think of this as an inflatable donut.
When complete, the habitat will look something like this.
A lot of people wonder, why are we looking at inflatables? They think of these as just big balloons, and why do we want to play with balloons?
Its outer shell is actually made from a durable Kevlar-like fabric.
It's extremely rigid, it's stronger than aluminum once it's inflated, and it's designed to be able to compress into a small area, but yet expand into a large volume once deployed on the surface.
It'll take several hours for the habitat to inflate to its full size. It expands outwards from a central core containing the electrical and life support systems. Along the curved outer wall sit storage units, as well as work and lab stations. An identical adjoining unit houses the crew's living and sleeping quarters. Entrances are fitted with airlocks and magnetic filters to keep out dust. But engineers have an even more lethal lunar hazard to contend with: radiation. Cosmic rays traveling from distant parts of the solar system constantly bombard the moon. And the sun unleashes streams of highly charged particles during sporadic eruptions called solar flares.
You go up there with even a spacesuit, and if there's a solar flare, you could be dead.
During their few days on the moon between 1969 and 1972, the Apollo astronauts suffered no ill effects from radiation. But many believe they dodged a bullet, something residents staying several months can't count on.
We have the ability to bury those outposts in lunar regolith, shielding, radiation shielding.
A jacket filled with regolith, the troublesome lunar dust, forms a dense barrier which absorbs cosmic rays, while inside a water wall shields astronauts from the higher energy radiation periodically produced by the sun.
So they'll go inside the protective confines of the water wall, and there they'll wait out the storm, just kind of like a tornado shelter in the Midwest.
It's now 2024, 4 years since humans returned to the moon. Over multiple missions, the lunar outpost has gradually grown in size, allowing its occupants to live and conduct scientific experiments for up to 6 months at a time. But they're still totally dependent on regular cargo shipments from Earth for all their supplies. If the outpost is to survive, they must find a way to begin producing their own oxygen, water, and other basic necessities. Flying all the basic necessities to the lunar outpost every few months is simply too costly. So humans must take another approach.
It's very important that when we return to the moon, that we do it with a mindset that is based on a frontier approach. A mindset that says, what can I do with the resources and materials that are here so that I don't have to bring them all the way from the Earth?
So step 8 for the moon dwellers is to find those resources locally. Surprisingly, one place may be right underfoot. The only geologist ever to wield his hammer on the moon is Harrison Schmitt. He and other scientists recognized that the same dust or regolith that poses such a threat to astronaut health and equipment also contains a treasure trove of valuable minerals.
Copy that. If you heat that regolith to, say, 700 degrees centigrade, some of it will react with the oxygen in the minerals of the regolith and the glass of the regolith and come off as water.
An intense effort is now underway to learn how to extract these riches within the lunar regolith. Back on Earth, a NASA team is experimenting with a new process on the slopes of the Mauna Kea volcano in Hawaii.
We found that the soil at that site is relatively close to the chemistry of the soil of the regolith on the moon.
They're working to produce not just water, but oxygen.
This dust, which will be several inches thick on top of material like this on the lunar surface, is the product we are mining. in the beginning of our process for utilizing resources on the moon.
They test out an experimental vehicle designed to turn pulverized rock into oxygen, hence its name, Roxygen.
So what we're doing in Hawaii, we have a rover that scoops up some of the soil, dumps it into a hopper.
Inside the vehicle, the soil is heated to a temperature of 1600 degrees Fahrenheit. The metal oxide in the soil reacts to give off water vapor. Within this water vapor is the crucial element oxygen. When fully developed, the Roxygen system will consist of an autonomous rover fitted with a scoop. The rover will transport the lunar dirt to a conversion plant where the water produced is separated into hydrogen and oxygen.
So the resources for humanity's expansion, once we get up there irreversibly, will come from this lunar hardware shop.
But those critical resources are found only in small quantities out on the exposed slopes. Scientists believe more abundant reserves may lie in the South Pole's deep, dark craters.
They're cold traps. They're permanently shadowed areas that trap things like water ice. That might have come from comets that impacted the moon.
Since each gallon of water costs $80,000 to launch into space, finding large quantities on the moon would be a real bonanza.
If you think about where are the equivalent of the Saudi oil fields in our universe, if there is frozen water on the South Pole of the moon, that's it.
But tapping into this bonanza won't be easy. It'll require step 9 of the lunar mission. Developing a vehicle that can cover long distances and descend crater walls deeper than the Grand Canyon.
It's really rolling hills, Joe.
The longest distance that they could travel from their lander was about 10 kilometers. And when we have the outpost, we need to be able to explore longer than just 10 kilometers. So we're working on a pressurized rover concept that will allow the astronauts and the crew to really traverse 100 kilometers, 200 kilometers.
And 2 sample bags, that would be...
But operating in remote areas of the moon will be risky. Get far enough away from home, and getting stuck or breaking down could prove fatal. In the rugged terrain of the Arizona desert, astronauts test whether the rover can get out of tough situations.
Each wheel can turn on its own. It's really a safety function, because if they get into an area that they just can't back out of, the rover can walk sideways, backwards with a 0-degree turning radius.
And this new rover has other features essential for long trips. Inside the pressurized cabin, the 2-man crew doesn't need spacesuits, just regular clothes. And the vehicle can support them for up to 2 weeks.
So, where do you want to head?
Let's go over to that crater.
Okay.
One of the features of this cabin is that there's a small bubble here in the front window. And so you can actually stick your head or stick a camera out when you drive up close to a rock.
When the crew finds something outside they want to take a closer look at, they can slip into a spacesuit attached to the back door. Part of the door becomes the backpack containing the life support system, allowing them to scoop up the sample and take it back to base. Even if they're successful in finding water and making oxygen from regolith, these early moon dwellers will still have to use resources sparingly. Astronauts will live in a tightly controlled environment that keeps waste to a minimum. Over 90% of the water they consume is recycled, which means that the coffee they drank yesterday morning, well, now it's simmering in tonight's soup. Their environmental and climate control system removes excess carbon dioxide and moisture from the air. It recycles the water and pipes the CO2 into the greenhouse next door.
Once we are able to get access to oxygen and water There will be the ability to grow food. You'll bring seeds. Then you have to bring some nitrogen, and you'll grow foods.
And the oxygen produced by photosynthesis from that food is returned to the living quarters. It's now 2040, and through a deliberate series of steps, America's established a permanent outpost on the moon. And like the early European colonies at Jamestown and Plymouth, this outpost needs a fresh wave of immigrants.
So that we can keep going.
Other nations and businesses will quickly follow, moving beyond the South Pole in search of profit or a strategic edge.
The things that we fight wars about on Earth today, those are the resources that are in space.
And on the moon. The real race for our nearest neighbor is just beginning. It's 2050, 30 years since humans returned to the moon. Regular ferries now operate between lunar orbit and the Shackleton spaceport. The original outpost has grown into a lunar city. Commercial domes, processing plants, hotel towers radiate out from its center. Hard to believe that all this sprang from a single module delivered by an Altair cargo flight just 3 decades earlier. And the Shackleton crater isn't the only place where humans have landed. Over the horizon, China and India have also established their own lunar bases.
One of the most fascinating things is going to be the race for which government and which societal structure will have predominance in space.
Thoughts like these may have spurred today's travelers. This flight is filled with business people and scientists here to help take the final step of the lunar mission, creating a self-sustaining economy.
That's how civilizations expand. And we have to do it in a partnership wherein the government helps support and catalyze the development of activities that can eventually pay their own way.
These new arrivals have their work cut out for them. One critical need is an abundant source of power. Without it, a self-sustaining economy will be impossible.
The RG is on? Yeah.
At the University of Houston's Nanotechnology Lab, Alex Freundlich has an idea for turning one of the moon's greatest threats, its lack of an atmosphere, into an advantage.
Can you press that up? Press it down? Yeah.
His team develops highly efficient solar cells which generate electricity from sunlight.
You got it? Yeah.
Here on Earth, these cells can only be produced in a vacuum created by constant pumping. But space presents other opportunities.
Now, all this machinery is utilized to create a vacuum of the size of probably a few inches in diameter. Whereas on the moon, I mean, we have that on hundreds of thousands of kilometers, naturally made.
Experiments in this miniature moon vacuum reveal something else. The lunar regolith, or layer of moon dust, spread over those thousands of kilometers, contains all the raw materials to make solar cells. It just needs to be collected and processed. So Freundlich's team has designed a robot. Using solar power, it first melts silica in the lunar surface to create a layer of glass. It then lays down a grid of solar cells on top of the glass. Putting multiple robots to work can transform hundreds of square miles of the lunar surface into vast solar farms. Because in many places it's always sunny, they can provide enough power not just for the moon, but for the Earth as well. David Criswell, also with the University of Houston, has an ambitious solar energy plan. Export that surplus power from the moon back to Earth.
Basis to deliver commercial power back to Earth would be about 30 to 100 kilometers across. and they would be located on the two edges of the moon. So over the course of a lunar cycle, one or the other would be illuminated. So it's the perfect place, in fact the only place that we can cost effectively gather enough solar power to run our planet.
These vast solar arrays convert the electricity into microwaves and then beam them to terrestrial receivers. Don't worry, they won't turn a passing airplane into a microwave oven. Its metal skin shields the passengers. And over 80% of these microwaves can be converted back into electricity, making them highly efficient. Another proposal for supplying the Earth with lunar energy suggests using the lunar surface in a different way. Mining it for a rare form of gas, helium-3.
Once you have lunar settlements in place, more than likely their primary source of export income will be by sending helium-3 back to Earth for use in fusion power electric plants.
Nuclear fusion, where helium-3 and hydrogen atoms fuse to give off energy like the sun, is still largely theoretical. But many feel the process holds enormous potential. Just 100 pounds of helium-3 could power a city the size of Atlanta or Helsinki for a year with little of the radioactive waste of conventional nuclear power. In the meantime, other minerals promise a quicker return for the lunar economy.
There are trillions of dollars of platinum and gold and precious metals from asteroids that have impacted the moon over the last 4.5 billion years.
Robot miners can plow up these valuable minerals without risk. The dead rock of the moon supports none of the Earth's fragile ecosystems. Just over the horizon from the lunar city lies the moon's far side, which always faces away from Earth. It's a place scientists can't wait to get to, not for development, but for studying the rest of the solar system.
The backside of the moon is the quietest place for radio astronomy to be found in the solar system. We can't get that kind of quiet on the surface of the Earth with all the radio noise that we have around.
Here, a giant radio telescope can peer into the remotest corners of space, searching for clues to how the galaxies and the early universe formed. This thirst for knowledge drives humans, but so does our desire for fun. By the middle of the 21st century, the lunar economy caters to a growing stream of tourists, ordinary people willing to pay a premium for the first true off-world adventure.
Why not wake up in your bed feeling 6 times lighter than you do on the Earth? Roll over and look out the window at that beautiful little blue-green orb and go down to the rec field.
That rec field and resort are housed in a giant dome.
Just imagine a pole vault in 1/6 gravity, or a high dive 6 times higher than the highest high dive on Earth, and what could happen before they hit the water. But what's really interesting is you can strap on a pair of wings, flap your arms, and fly. The oldest dream of humanity realized.
And old dreams inspire new ones.
There is a solar system out there, waiting for human beings to enter it and to figure out how to use it to our benefit if we can, and I'm convinced that we can.
Throughout history, the moon has mesmerized humankind with its silvery mystery. It's an alien world, and yet it's close enough that we can discern its individual features and feel its tidal pull on our oceans. Whoever builds the rockets, the vehicles, and the systems that take humans back to the moon, whether it's NASA, China, or private industry, the venture will usher in a new era. No longer will space be a hostile place that we occasionally visit.
We're going to be seeing ourselves not as just one world, the Earth, but the Earth and Moon together as a system. And between, we'll have orbiting hotels and facilities. We'll have cycling ships that just do figure eights between the Earth and the Moon permanently.
The Moon may soon become a testing ground where we hone exploration skills, develop the technology to harvest resources on more distant planets, and begin mapping out our future as a spacefaring species. By going back to the Moon, we prepare ourselves for more ambitious journeys. Journeys that may ultimately take us to Mars and beyond.